Okay, class. Well, in this video, I would like to talk about another descriptor for statistics, which is the dispersion. Okay, we are going to introduce what is the meaning of dispersion in a data that we collect in a survey, in a sample of data. Okay, so that data might come from, as we mentioned, as a sample, or probably is coming from the whole population. So we want to know how that data is spread. Okay, so there are two answers. One is the range and the other one is the standard deviation. That's what we're gonna discuss in here. Okay, so let me just open this presentation in here. Again, you don't have this slide, but well, you have this video, and also in your D12 you have a very detailed presentation about dispersion. But let's say that this is a plot of the distribution frequency that we create in our samples. And for instance, like the ones that we have in the spreadsheet that I gave you. Let me just to show you that one. This one here. Okay, this one here, for instance. Okay, this histogram. Okay, well, so we have here in this presentation a sketch. Okay, and we ask, well, this curve here, which is a histogram, represents some data, and this curve here, the second one, represents another set of data. So we say, okay, which one of the two histograms, of which one of the two data are more dispersed? Okay, so well, one answer that we can make is to say, well, let me see the range of the data. I mean, compare what is the distance between the lowest values and the highest one. And that is going to give me an idea of how dispersed is the data. If the range is very large, okay, well, I might think that the data is very spread out. But if the range is small, probably the data is more concentrated, is less dispersed. And that's what we have here. So for instance, if we look at this curve here, we look the lowest value and we look here at the highest value. If we compare this distance between this one here, really this one is smaller, and we can say, well, is less dispersed. But really, this is not the best way to approach the dispersion, because it is better to say, well, is dispersed respect to what? Okay, and I think that that is most important, because putting the reference, and we say, well, is dispersed or spread respect to this reference, is going to give you more information, because the reference probably might be a descriptor that is very relevant. For instance, the mean. Okay, if you say, well, my data is more spread respect to the mean, that is very important, because you know that the mean is the central tendency of the data. And this is another way to measure the dispersion. For instance, if you look here at the data, of course, the histogram is a kind of very typical histogram that we're going to look for or discuss later on. It's like a bell-shaped histogram. This red line here represents the position of the mean. That means that the central tendency of that histogram is around this point. So, for instance, this curve in here, this histogram, that is more dispersed, is more spread out, really spread out from the mean more than this one in here. So we can see that another way to measure the dispersion is to measure in general how far in general the data is from the mean. If that distance from the mean is larger, then we say that the data is more dispersed. But that information is more relevant compared to the range because we are making the calculation respect to a reference, and that reference is very important. For instance, is the mean, which is a descriptor of the data. Okay, well, this approach is what triggers the concept of the standard deviation. Okay, so, and this is what we have in here. Okay, let me show you here back the data. Well, if you look at the histogram of the previous example that we show you, okay, you can see this is the mean, this is the median, okay, and you can see looking to the right of the histogram, it is more dispersed compared to the left. So what we expect to have is that respect to these two positions or to these descriptors, the data is more spreading, is more spread, or is spread out more respect to the center tendency compared to another set of data that probably the histogram might be around here. Okay, so if we compute the standard deviation of this standard deviation is going to be larger, like if you compare with an histogram that ends up over here, for instance. We are closer in this situation to the mean rather than in this one, the dispersion is larger because we are far away or more far away in the data from the mean. So, in other words, what the dispersion is measuring to you is how spread or dispersed is the data. We can do a comparing the lowest and largest one values, or we can measure the distance of the data in general respect to the central tendency. And normally, the ones that we use as descriptor for the central tendency in order to compute the dispersion is the mean. Here you have the way to compute the standard deviation, which is this dispersion that measures how dispersed we are from the mean from one of the central tendency descriptors, which is the mean. So what we normally do is, well, we take the data, remember that this is the sorted data, we subtract the mean to the data, so for instance, in this one, this is this value minus the mean was, well, I put it here 70, but really the mean was 70.93. So we made that one for each one of the samples, okay? And then we squares those differences. So this one, this value here, is the square of this one over here. You see? So this value here is the square of this value over here. Okay? Then we add all those squares. So we repeat everything for each one of the outcomes to get this value here, which is the summation, is this portion over here. And we divide it by the length of the data minus 1. The length of the data minus 1 is 30 minus 1, which is 29. Okay, we divide it by that. That's what we made over here. So we have A33, which is this value over here, 190, divided by 29. And that is going to give me 6. And then we take the square root of that ratio, this ratio over here. Okay, and this is what is called the standard deviation is around 2.45. Okay, so one standard data that is one standard deviation from the mean is to take the mean value, that in this case I suppose that was 17, is to take the mean value and add this number. So, for instance, 17 plus 2.45 is going to be around 1945. So all this data over here, okay, for instance, this one is around one standard deviation from the mean. And all these guys are more than one standard deviation from the mean. So those are outliers, really. They are very far away from the mean. Okay, that's what we want to try to say with the standard deviation. Let me see if there is something else that I want to tell you about this in here in my presentation. Okay, that was this example. For instance, this is another example. This is another set of data. In here, I'm using another statistical application, which is called StatCrunch, but don't worry about that. You are going to use that one. Okay, the red value represent in here the median, and the mean value represent the green. When you have histograms that are no center, I mean that they are leaned to the right or leaned to the left, those kind of histograms, they are called skewed histograms. If the histogram is leaned to the right, okay, we say that it's skewed to the right. If the histogram is leaned to the left, we say that it's skewed to the left. And in all of them, normally the mean value is going to be greater than the median. If it's skewed to the right, the mean value will be greater than the median. If it's skewed to the left, the mean value will be lower than the median. Okay? Normally happen those kind of things. And I think that I have another slide for doing that. But the point that I want to make in here, this is the histogram, and you see that this histogram is quite dispersed around the median or around the mean, because you have outcomes that are really far away from here. Actually, in here, they compute the standard deviation is 5,000, around 5,300. So if this is the mean value, for instance, this value here is one standard deviation from the mean. But this one is almost, is more than 3 standard deviation from the mean. It's almost 4 standard deviation from the mean, because this outcome is 20,000. So if you multiply 4, if you multiply the mean value is 3,000, so this is around 17,000 far from the right. 17,000 is a little bit more than 3 standard deviation. It's almost 3.5 standard deviation from the mean. So that's what we can interpret about the data. So remember, in here, remember this graph because this is very didactic, okay? So if the data spread more from the mean, so the data is more spread out more compared to probably another set of data. So the dispersion is greater, is larger. If the data is close to the mean, then we say, well, the dispersion is really lower. We don't have so many outliers. One way to measure that dispersion is the standard deviation. And the way to compute the standard deviation was the ones that I told you in the presentation, which is to follow these kind of things that is in here. Okay, to follow this workflow in here. Okay, so well, this is what I want to tell you in this. Oh, the final comment is this one. Okay, we have histograms that are very, that are concentrated, is like a bell shape. Okay, so for instance, this one, this is another example. This is like a bell shape. It's not perfect bell shape, but it's more center. Okay, but there are some other histogram that they might be skewed to the right, in which the mean is greater than the median, or they might be skewed to the left. And those are the samples that I showed you here. For instance, in our example, this histogram is skewed to the right. Okay, and for instance, in this example, also this histogram is skewed to the right as well. Okay, well, this is what I want to tell you about dispersion, guys. Thank you. What is